Hi everyone. Welcome to my channel. DC, Explore the World. Well, after a delightful welcome, let's explore the topic related to our universe. On one side, we all loves to hug our nature, and it's all beauty, and on the other side, we also need to be introduced with the hazards, whom can birth the big and doom to our Earth or our universe. Our universe is so biggest than our imagination, so vast with the hectares of water, land, or the dozens of planets. And with the unconditionally, galaxies of billions of stars. The best thing for all of humanity, that our scientists' exploration, the universe, and step by step to experimenting all the planets close by Earth. When we name the solar system, the first thing come in all of us minds is only one super firm. NASA. We define NASA as National Aeronautics and Space Administration, called Very Long Baseline Interferometry, was developed, said Franz Cordova, director of the National Science Foundation, which coordinates the EHTE. This team took that concept to a global scale. The collection of the data was completed in barely a week, but the collation and analysis of it took the better part of the past 2 years. The researchers from the different observatories divided into 4 teams, and worked independently, sharing no information among themselves about preliminary. Well, here it needs to be splitting because of the casualties and threats from black holes in the space, the gas waterfall, and a new comet entering into our solar system. So let's begin with the black holes. The black hole at the center of our galaxy goes by the name Sagittarius A*. It has a mass equivalent to about 4,100,000 of our suns. While that earns it the sobriquet supermassive black hole, more common black holes can be as small as 5 solar masses. It's actually something of a pipsqueak as these things go. It measures perhaps 24 million miles across, or about a 50 billionth the size of the galaxy. Trying to take an image of that from the 26,000 light-year distance at which the Earth sits from the center of the Milky Way is like trying to spot an orange on the surface of the moon with the naked eye. A picture of Sagittarius A* was not released Wednesday, but will be in the future. It's the most distant black hole ever detected, from when the universe was just 5% of its current age, around 690 million years after the Big Bang. Gathering all this mass in fewer than 690 million years is an enormous challenge for theories of supermassive black hole growth, said Carnegie Mellon University's Eduardo Banados, who led the study. Previously, the earliest known black hole was from when the universe was about 800 million years old. The black hole in question, 1342 plus 0928, sits in the center of a super bright disk of orbiting gas, in the center of a galaxy, forming an object known as a quasar. It was discovered in the data from 3 large area surveys, Z-band data from the Decom Legacy survey at the CERA, April of 2017, a global web of 8 radio telescopes located in 6 places: Chile, Mexico, Spain, Hawaii, Arizona, and the Antarctic. The collective network that makes up the EHTE began surveying the Messier 87 black hole, as well as the black hole at the center of our own Milky Way galaxy. Seeing any sign at all of either formation was no small achievement. As it sweeps through our neighborhood of space, astronomers are rushing to study this object. This week, October 14, 2019, the Hubble Space Telescope released the image above of 2I/Borisov. Also, astronomers in Poland published the first peer-reviewed paper about it, discussed below. New Hubble Space Telescope image of comet 2I/Borisov. The image above was acquired on October 12, 2019, when the object was approximately 260 million miles, 420 million km from Earth. It shows why, unlike Oumuamua, which was hard to distinguish as either definitely asteroid-like or definitely comet-like, The second interstellar object is now confirmed as a comet from another solar system. The Hubble image reveals a very comet-like central concentration of dust around a solid icy nucleus. Astronomer David Buckley, leader of the Hubble team, who observed the object, explained in a statement, "The birthplaces of planets are disks made out of gas and dust. Astronomers study these so-called protoplanetary disks to understand the processes of planet formation." Beautiful images of disks made with the Atacama large millimeter/submillimeter array, ALMA how distinct gaps and ring features in dust, which may be caused by infant planets. Last year, 2 teams of astronomers demonstrated a new planet hunting technique using this gas. They measured the velocity of gas rotating in the disk around the young star, HD 163,296. Localized disturbances in the movements of the gas revealed 3 planet-like patterns in the disk. In this new study, lead author Richard Teague from the University of Michigan and his team used new high-resolution ALMA data from the disk substructures at High Angular Resolution Project DSHOP to study the gas's velocity in more detail. With the high-fidelity data from this program, we were able to measure the gas's velocity in 3 directions instead of just one, said Teague. For the first time, we measured the motion of the gas rotating around the star, towards or away from the star, and up or downwards in the disk, unique gas flows. Teague and his colleagues saw the gas moving from the upper layers, towards the middle of the disk at 3 different locations. What most likely happens is that a planet in orbit around the star pushes the gas and dust aside, opening a gap, Teague explained. The gas above the gap then collapses into it like a waterfall, causing a rotational flow of gas in the disk. This is the best evidence to date that there are indeed planets being formed around HD 163,296. But astronomers cannot say with 100% certainty that the gas flows are caused by planets. For example, the star's magnetic field could also cause disturbances in the gas. Right now, only a direct observation of the planets could rule out the other options. But the patterns of these gas flows are unique and it is very likely that they can only be caused by planets, said co-author Ian Bailey of the Carnegie Institution for Science, who tested this theory with a computer simulation of the disk.